All right, today we are doing dilations. It's the fourth of the transformations that we've done in class. This one's very simple, and on the surface of it, dilations are not terribly exciting, but they are important. Dilation is when we shrink or stretch an object, but we do it proportionally. That means everything, when we make something bigger, if I make it 3 times bigger, then all sides are 3 times bigger. And if I make it 3 times smaller, then all sides are 3 times smaller. The scale factor for dilations is very important because it's the scale factor that tells us how much to shrink or to stretch. When we are looking at sides or we're looking at coordinates, the x and the y of a point, we multiply our scale factor by those points and by those side lengths to get the new figure. I'm going to start and keep this kind of easy today, and I'm going to go with a regular polygon. Actually, that's not true. I'm going to go with, meant to say I'm going with something kind of simple. I'm going to go with a triangle today, and there's my triangle. This is a isosceles triangle, and I'm going to dilate it. First I'm going to make it larger, then I'm going to make it smaller. So let's, before I do that though, I do want to get the value of each of my figures. Name and value. Alright, so to dilate, we use these same tools we've been using here. It's the 1, 2, 3rd from the right. I need to tell you something very important. In Geogebra, when you dilate, we dilate from one point. Right now, I'm going to dilate it from the origin, the center point down here. Do you see me down here? I had already put that point in. If you do not have it, you'll need to go to the point tool up here and put that point in right there, and something happened. Nope, we want to stop that. Alright, so I've got my point down here. Alright, so let's dilate this. First, I'm going to stretch it, make it larger. So I'm going to go here, and it's going to say to dilate from some point. Click that. It says to select the object, then the center point, and then we have to enter a scale factor. So I'll click the object. I'll I'll click the point of origin, and then I want a scale factor of 3. Let's go with 3 and say OK. And there we have our image that's now 3 times bigger. How do I know it's 3 times bigger? Well, look at the points. Point A started out at 1, 1, but now A prime is 3, 3. Well, 1 times 3 is 3. This 1 times 3 is 3. We'll look at point, let's go down to B. 3 times bigger, well, 3 times 3 is 9. 1 times 3 is 3. And then finally point C. 2 times 3, yep, 6. 3 times 3, yep, 9. So this is 3 times bigger. Let's now, I'm going to move this up a little bit. Now I want to make this thing smaller. Let's make it 3 times smaller. So again, I'll go to my dilation tool. I'll click my object, my point of dilation. When I put in my scale factor of 1/3, I'll put it in like this. 1 divide by 3. That's how we write 1/3. We'll say OK. And ta-da! Here it is. Now these new points are a little bit hard to... All right, here's point B. Here's point A. It's only going to move so far. I'll put it here. And here is point C, the new point C. So you can see that each of these, now it's given it to us in decimal form, but that's okay. 1/3 of 2 is 2/3. 1/3 of 3 is 1. and so on. So that's how you dilate. All right. Now I want to show you what happens when you dilate from a point other than the origin. It's still going to get larger. It's just going to put it someplace different. So I'm going to click here and go point. Oh, let's just put it right here. Let's just put the point out here somewhere. So again, I'm going to dilate my original, my pre-image. Dilate from a point here. Click my point. Let's have this one get 2 times bigger and say, okay. Oh my goodness. It came all the way down here from this point. The question is, why did that happen? Interesting. It's not going to move. But what happens when I move my point? Oh my goodness. If I come here, it would have gone there. If I go here, and here, and here. Wow. Pretty cool math, huh? And I'll be honest and tell you, I'm not quite sure why that's happening. I'm going to go ahead and put it back here. And there we go. So we have our original pre-image. I'm going to make my pre-image. I like green, so my pre-image is going to be green. Then my second image. I want to make my second image blue. Let's leave this third image transparent, but let's make it that color blue. And let's come down here. Get this one. And let's make that one. I think that's purple. Not sure. Yeah, that's purple. So there I've dilated my original to be 2 times bigger, 3 times bigger, and 1/3 the size. I've dilated everything from the origin, and that's how you dilate in Geogebra. You're going to have to answer some questions from the Google Doc that have to do with the coordinates. One more thing we want to do, I just remembered. I want to talk to you about the sides. This bottom side here, when we started with the pre-image, it is 2 units long. When I look at the figure that I dilated by a scale factor of 3, look how long it is. 1, 2, 3, 4, 5, 6 units long. So I went from 2 to 6 because 2 times the scale factor 3 is 6. This one I dilated by a scale factor of 2 is 1, 2, 3, 4 image. 4 units long because 2 times the scale factor 2 is 4. And finally, with 1/3, this here is 1/3 because 1/3 times 1 is 1/3. And that, my friends, is dilations. Thanks a lot.